All right, because I've done so many of these problems, I recognize this right away when I read the question. It says, is there a time C between 1 and 9? So you have to be careful, okay? We're going 1 to 9 and we're using the graph of G. So we're starting here and going to here. Now sometimes I'll say like from 4 to 9, so you have to be real careful that you're looking at the correct data values, such that G prime is equal to -1/2. So it's saying that the slope is -1/2. So this is a mean value theorem problem. Mean value theorem. It's not asking if G of C is equal to -1/2, which would be an intermediate value theorem. It's asking the derivative equals -1/2. So when it's the derivative, it's the mean value theorem. And what the mean value theorem really says, I think of it as the slope is equal to the derivative. So what you're writing is like I guess we're using G. So we'd want to use G of 9 minus G of 1. We're doing slope. So change in Y over change in X, 9 minus 1 is equal to the derivative at some point C. So does this happen? Now it says here, using the table values, our Y values at 9 and 1 would be -1 and 3. So we're looking here, -1 minus 3. So in the numerator, we have -1 minus 3 over 8, which gives us -4/8, which is -1/2. So does that equal? Yes, by the mean value theorem here. So we want to make sure when we're using the mean value theorem, obviously it's a yes here because it equals a -1/2 that we need. We want to say yes, G is differentiable and continuous. If it's not those things, this wouldn't work. And we know it is because it says it in the problem. G is twice differentiable. If it's differentiable, then it's continuous. So yes, G is differentiable and continuous from 1 to 9. So the mean value theorem guarantees at least one number C, and you're using C, that's what the theorem actually uses also. So mean value theorem guarantees at least one C. Between 1 and 9. Such that the derivative equals that -1/2. Such that G prime of C equals -1/2. There we go. So that would be a very complete answer for that one.